Hi class, for example 3, we're going to look at 3 types of problems. And here's the main idea. If your equations that they're asking us to provide sketches from look like formula 1, 2, and 3, they're going to be producing lines that are going to be increasing or decreasing. And you read this from technically from left to right. In this case, you can see the line is going up. And from left to right, the line is going down. Okay, the main objective here is they're going to want us to see a total of 3 coordinate points. And if it's not stated, you pick the coordinate points. So let me take a look at the first problem. And in this particular problem, you're given an equation of y is equal to 2x minus 1. And they haven't told us anything about the coordinate points, so we're going to pick them. So let's actually pick wisely. In this case, well, let's start with 0. It'll be easy to simplify. And you're going to end up with y is equal to 2x minus 1. Remember that all of these are evaluations, so you're going to plug in the 0. And this is going to give us y is equal to 2 times 0 minus 1. Or negative 1. So y is equal to negative 1. Your coordinate point that we're going to be using, it's going to be 0 comma negative 1. And let me plot it here. That's going to be the first one. Let's just use a positive value. So in this case, for the second point, let's use x is equal to 1. And we have y is equal to 2x minus 1. And once again, remember that we're using the value of 1. So y is equal to 2 times 1 minus 1, or 2 minus 1, which is 1. So your y value is 1. As a coordinate point, we're looking at 1, 1. So on the graph, that's going to be here. And we'll select another one, since they do want a total of 3 coordinate points. And just because of symmetry, let me use a negative. So let's use negative 1. So we're going to end up with y is equal to 2 times negative 1 minus 1, or negative 2 minus 1, or negative 3. So your y value is negative 3. Your coordinate point is negative 1 comma negative 3. And let me actually fix this. Okay, so negative 1, negative 2, negative 3, it's going to be here. Here we have the 3 coordinate points. And let me actually attempt to draw a straight line through those 3 coordinate points. In this case, we're just doing a basic sketch, so that happens to be our line. Assume that it's a straight line. I can't really use a ruler here. And our coordinate points happen to be here. As you can see, that is what represents a line. So in theory, you would be using a small ruler, but all of these are going to produce these types of lines. Okay, let me go to problem 2. In this case, problem B. And notice the problem B represents, in this case, formula 2. And same idea, they want us to find a total of 3 coordinate points. So I'll pick values near the origin. So let me pick 0. So in this case, let x equal to 0. And we're going to end up with 4x minus y is equal to 5. And as we plug in the 0, we're going to end up with 4 times 0 minus y is equal to 5, or negative y is equal to 5. And let me just do a quick division of a negative. and we would end up with y is equal to -5. So from this coordinate point, we found the first one, which happens to be 0, -5. And let me plot it, which is going to be here. That's going to be our first coordinate point. For the second one, let me actually use 1. So let x is equal to 1. We're picking coordinate points that are close to the origin, but we also don't want to pick coordinate points that may create fractions. So in this case, we have 4x minus y is equal to 5. And plugging in the 1, we're going to end up with 4 times 1 minus y is equal to 5, or 4 minus y is equal to 5. Let me subtract the 4's, and this will give us negative y is equal to 1, and then we'll do a final division of a -1, which is going to give us that y is equal to -1. So for this particular one, as an x and a y, we're looking at 1, -1. So 1, -1, it's going to be here. And the last coordinate point that I'm going to pick, let me pick a negative. So let me pick -1, 2. Or actually, in this case, just because it's going to be a little bit hard, let me see if... no, -1 is fine. So in this case, let x is equal to -1. And we're going to end up with 4x minus y is equal to 5. And then plugging in, that would give us 4 times -1 minus y is equal to 5. So -4 minus y is equal to 5. And then we're going to be adding the 4. Which will give us -y is equal to 9. And then we'll do a division by a -1, which will give us that y is equal to -9. Let me just move this here. And then write our solution. In this case, as an x and a y, you're going to end up with -1, -9, which is going to be a little bit hard to plot given the scale. So that's going to be here. And then also, let me draw the line. And our line is going to be going through those 3 coordinate points. You're assuming that you have a straight line. Let me see if I can fix it. That it's going to go through those 3. My apologies. And here you have the 3 coordinate points. That's actually it. We're just basically doing basic sketches for all of these. But that's it for problem B. Once again, problem B fits formula 2, except that it has a negative. Let's take a look at problem C, and we'll do the same. We'll pick coordinate points. So let me pick, in this case, x is equal to 0. I'm always picking values that are near the origin, and then also we're avoiding fractions. So in this case, y minus 3 is equal to 2 times x plus 2, and we're going to be plugging in the 0. You could also simplify the equation that may actually be best. In this case, y minus 3 is equal to 2 times 0 plus 2, or y minus 3 is equal to 2 times 2, or y minus 3 is equal to 4. And then we're going to be adding the 3. So y is equal to 7. Our coordinate point, it's going to be, in this case, 0, 7. Also, if you don't use coordinate points near the origin, you may be outside of the scale. So 0, 7, it's going to be here. And let me actually pick another point. So let x is equal to 1. So you're going to end up with y minus 3 is equal to 2 times x plus 2, or y minus 3 is equal to 2. Wait, x is equal to 1, so 1 plus 2. So y minus 3 is equal to 2 times 3. Y minus 3 is equal to 6. And then we're going to be adding the 3, which will give us that y is equal to 9. Y is equal to 9. So at 1, we're at 9. So that's going to be here. And let me just close the line. We'll do another coordinate point, but it's going to look crooked like we did on the previous one. So let me just pick a thicker. Okay, and let me just point out the 2 points that we found so far. They want 3 coordinate points. That was on the main instruction, so I'll pick another one. But I wanted to show you something. So let's say that we pick -1. So let x is equal to -1. But the given equation, you have y minus 3 is equal to 2 times x plus 2. So what you could do here, and this may save you a little bit of work, is technically distribute the 2. So you're just modifying the equation. It may be easier for another problem. And this is equal to 2x plus 4. And then we're going to be adding the 3. And this may just be easier for the evaluation. So in this case, y is equal to 2x plus 7. And we're using x is equal to -1. So it'll be equivalent to plug it in into the simplified equation, as opposed to plug it in like I did on the previous one, where given the equation we plugged it in and solved. And I'm referring to this portion here and this portion here. So in this case, your y value, it's going to be -2 plus 7, or y is equal to 5. As an x and a y, the next coordinate point would be -1, 5. And you can see here that the point is actually getting there. So -1, 5, it's technically right there. Once again, we're just doing a basic sketch. And I also wanted to do this problem where we modified the original equation, just so that you see that it's not necessarily needed to use the original one, especially because some of these will cause fractions. That's actually it for this problem. This example has 3 types of problems where we're plugging in 3 coordinate points.